I said we'll make this quick so you guys can get some practice reviewing this. So, we talked about at the end of November, when we're solving equations, doesn't matter if it's a 1-step, 2-step, 3-step, 4-step equation, when we're solving them, our goal is to get the variable all by itself. To do that, we want to use inverse operations to get all of my variable terms on one side and all of my constant terms on the other side. All right? So I want all my variable terms typically to the left, even though it doesn't really matter, and my constant terms over on the right. So if we start out simple with a nice 1-step equation, again, the first thing we want to do is separate our equation into 2 parts right through that equal sign. When we use those inverse operations, we have to do them on both sides. So we want to make sure we know where my 2 sides start and end. Doesn't matter as much in a problem like this, but it will, especially once we finish out the unit with some more complicated stuff. So if we have negative 3x equals negative 12, that's my whole equation. Who could tell me what's my variable term or terms there? Negative 3x. How do we know it's a variable term again? It's got a variable. So what's my constant term? Negative 12. Constant is just another word for number, right? So if there's a number that you see with no variable on the end, that's a constant term. Now you'll notice here, we have one yellow term on the left, one pink term on the right. There's no real movement that we have to do. So all we have to do is divide if we want to get x all by itself. Because take a look, if we've got negative 3x, that's like saying negative 3 times x. And what's the opposite or the inverse of multiplication? Division. Thank you. Division, right? So if we're multiplying by negative 3, we want to do the opposite of that, which is dividing by negative 3. What is negative 3 over negative 3 on the left? We just get x, right? They cancel out because negative 3 over negative 3 is just 1. And when we have a 1 in front of x, we don't need to write it. So we've got x on the left equals, what's negative 12 divided by negative 3 going to give me? Positive 4, right? A negative over a negative gives me a positive, just like that. So this is what we call a 1-step equation. The only step we have to do is dividing both sides by this number in front. Anyone remember what the number in front of a variable is called? Starts with a C. Coefficient, right? So in a 1-step equation, we divide both sides by the coefficient. It's a 1-step equation. We know it's a 1-step because we only have one term on the left, one term on the right. Okay? Questions I can answer about 1-step. Pretty straightforward, right? 7th grade review. Let's take a look at a 2-step. Let's say we've got 2x plus 3 equals, I don't know, 7? Sure, 7. Works for me. First thing we want to do, split our equal sign up, as always, and then we can highlight. What are my variable terms here? Do I have any? 2x, good, there's a variable there on that 2. What are my constant term or terms here? 3 and 7, both of them. So now because all of our terms aren't sorted correctly, right? We've got a pink on the left and a pink on the right. This is going to turn into a 2-step equation. which which means before we divide both sides like we did in the first example, we've got to bring that plus 3 over to the right. What would the inverse operation of plus 3 be? Minus 3, right? I heard someone say it. Minus 3. Minus 3. Whatever we do to one side, we have to do to the other to keep our equation balanced. What happens with this plus 3 minus 3 here? Cross them out. Equals 0. Leaves me with 2x equals 7 minus 3. Well, that's just 4. So that's the first step in our 2-step. Now the second step is going to be to do what? Divide both sides by 2. Remember, we want that x all by itself. Right now we're multiplying x by 2. The inverse operation of multiplying would be dividing. Just like we had here, plus 3 minus 3 canceled out. 2 divided by 2 also cancels out. And 4 divided by 2 gives me 2. There's my answer. X is equal to 2. So each step is a different inverse operation when we're solving an equation. In a 1-step, all we had to do was divide. In a 2-step, first we had to subtract to cancel out with that positive 3. We could even highlight again here my 2x and my 4. And now that turns into kind of like that first example of a 1-step equation. Let's go ahead and add those highlights in for the second step. What's that? No, you don't have to highlight on the worksheet. We're doing the highlight in our notes just so when you refer back to your notes, your brain can see what you're doing each step. But I assume we're comfortable with it enough now. You don't have to. Great question. All right. Now we also talked about a little process called combining like terms. So if we have something like 5x minus x equals 16. I'm going to split my equal sign like always. I'm going to highlight my variable terms, which are 5x and minus x. What number's in front of that x again? Just a 1, right? It's that invisible 1. And what type of term would 16 be? Is that a variable term? Well, does it have a variable on it? No, so it's a constant term. In the previous example, we had 2 pink terms, but they were on opposite sides of the equation. In this one, we've got 2 yellow terms, but they're on the same side of the equation. So what we have to do here, let's write off to the side, is combine like terms. When we combine like terms, we don't use inverse operations. We just combine them, add them together, subtract them from each other, whatever it tells you to do. So if I have 5x minus 1x, if we remember, we can bring out the 5 minus 1. In front of the x, just like that. Right? If I have 5 x's and I take 1 x away, how many x's do I have now? 4. So 5 minus 1x just gives me 4x. So now I went from 2 separate variable terms on the left. I combined them and got 1 single yellow variable term on that side. Now we're right back to our basics, which is a 1 step. All we got to do is divide both sides by what? 4. That's right. When we do that, these 4's cancel out. And what would 16 divided by 4 give me? Just 4. That's right. So remember, don't use inverse operations if you're combining 2 like terms on the same side. Extremely important. If they're like terms on opposite sides of that line, that's when we have to do inverse operations. But if they're both on the left or if they're both on the right, just combine them up. Nice and easy. All right. Oops. We'll do one more example. I got to flip it over this, so I want to make sure everyone's got this down. What's up? Oh. Last but not least, after combining like terms, we took a look at having variables on both sides. So let's say we've got 5x minus 4 equals 3x plus 6. I'm going to split my equal sign. Again, just so we can see exactly what we're moving where, I'm going to highlight. 5x, that's a variable term. Minus 4 is constant. 3x is also a variable term. And positive 6 is constant. And this is just like our warm-up. Got a yellow and pink on the left. Yellow and pink on the right. Bring the yellow term to the left. Bring that pink term over to the right. And then divide. Right, so I want this 3x to join up over here. If I want to get rid of it on this side, though, I have to do the opposite. What would the opposite of positive 3x be? Negative 3x. And I'm going to do that over here on the left side as well. Minus 3x. Three x's on the right get crossed out. What's 5x minus 3x? 2x, that's right. Minus 4 equals 6. I'm going to update my highlighting there. And we see that now we only have one variable term, and it's on the left, 2x. Now we got to bring that constant term over to the right. So what's the inverse of minus 4? plus 4. All right, we're almost done. Stay with me. All right, negative 4 plus 4 goes away, leaving me with 2x equals, what's 6 plus 4? 10. So now I've got one variable term on the left, one constant term on the right. We're right back to where we started with that very first example. Yellow on the left, pink on the right. Yellow on the left, pink on the right. All we have to do now is divide. What are we going to divide both sides by? 2. These 2's go away, leaving me with x equals what? 5. Remember, we're dividing 10 divided by 2, not subtracting 10 minus 2. That gives me x is equal to 5. So if the highlighting helps, definitely continue that process on the worksheet. You do not have to highlight on the worksheet, all right? But if I see that you're doing things wrong or getting a little bit confused, I'm absolutely going to recommend that you do start highlighting, because it keeps everything nice and organized, and it trains your brain to kind of know what to look for. But like I said, some of us already kind of get it without highlighting, so that's fine if